Hello friends, welcome to HP Vibrant Academy. In the last lecture we have discussed up to question number 8, so we will discuss question number 9 onwards in this particular lecture. So basically we are discussing the problems on the concurrent forces. So in the last lecture we have discussed about the concept of circumcenter, orthocenter and the incenter. So there is one more concept, that is centroid. Okay, so let us discuss this. So centroid of a triangle is the point where the three medians of the triangle intersect. A median is a line segment connecting the vertex of the triangle to the midpoint of the opposite side. Okay, so let us understand this. So we have a triangle like this. Okay, so we have, let us take the vertex as A, B and C. Okay, and we have the midpoint of the sides as, let us take this midpoint here. Okay, and midpoint of AB is somewhere here. Okay, so the medians are, the median is line joining the vertex to the midpoint of the opposite side. Okay, this is the median. Okay, so let us join B to the midpoint of AC. Let us join C to the midpoint of AB. Okay, so this is our centroid. Okay, one more concept is that the centroid generates three triangles. Okay, so this is triangle 1, this is triangle 2, this is triangle 3. Okay, so the area of triangle 1 is equal to, the concept here is that area of triangle 1 is equal to area of triangle 2 is equal to area of triangle 3. Okay, is equal to 1 by 3 of, is equal to 1/3 of, is equal to 1/3 of area of triangle ABC. Okay, so this is the concept of the centroid. Okay, so let us discuss this question number 9. Okay, so we have ABC is a triangle. Forces PQ are acting along the lines OA, OB and OC are in equilibrium. Prove that if O is the incenter of the triangle ABC, then P is to Q is to R is equal to cos A by 2 is to cos B by 2 is to cos C by 2. Okay, so let us discuss this. So let us draw a triangle. So we have a triangle like this. Okay, and we have the incenter. Let us consider the incenter as this particular point. Okay, so incenter is the line joining the angle bisector. Okay, so let us take this vertex as A, B and C. Okay, so let us draw the line angle bisector. Okay, so this is the incenter. Okay, so these lines are the angle bisector. Let us consider this whole angle is B, so this is B by 2. This whole angle as C, so this is C by 2. Let us name this as O. What is this angle? Okay, so we have the triangle like this. This is O, this is B and this is C. So this angle is B by 2, this angle is C by 2. So what is this angle? Let us take this as BOC. So angle BOC is equal to pi minus B by 2 plus C by 2. This is pi minus half of B plus C. Okay, and we have the sum of angle A plus B plus C is equal to pi. So B plus C is pi minus A. So this is pi minus half of B plus C is pi minus A. So this is pi minus pi by 2 plus A by 2. So this is pi by 2 plus A by 2. Okay, so angle BOC. Angle BOC is pi by 2 plus A by 2. So this angle is pi by 2 plus A by 2. Similarly, this angle is pi by 2 plus B by 2. And this angle is pi by 2 plus C by 2. Okay, and we have the forces as, so we have the forces as, okay, the forces PQ are acting along the lines OA, OB and AC. So along OA we have this P, along OB we have Q, along OB we have Q, and along OC we have R. Okay, so we have the forces as P, this is Q and this is R. Let us write down the angles. So we have the angle as, so this is pi by 2 plus A by 2, this is pi by 2 plus B by 2, and this is pi by 2 plus c by 2. So let us apply the Lami's theorem. So on applying the Lami's theorem, we have, let us apply the Lami's theorem. So we have P upon sine of angle between Q and R is equal to Q upon sine of angle between P and R is equal to R upon sine of angle between P and Q. Okay, so we have P upon sine of angle between Q and R is sine of pi by 2 plus a by 2 is equal to Q upon sine of angle between P and R. P and R is this one, pi by 2 plus b by 2 is equal to R upon sine of angle between P and Q. This is pi by 2 plus c by 2. Okay, so we have P upon cos of a by 2 is equal to Q upon cos of b by 2 is equal to R upon cos of c by 2. So we have P is to Q is to R is equal to cos a by 2 is to cos b by 2 is to cos c by 2. Okay, so this we have to show in the question. Okay, so let us discuss second part. If O is the centroid of a triangle ABC, then P is to Q is to R is equal to OA is to OB is to OC. So let us solve this. So we have the triangle as the centroid. Okay, so let us draw the triangle like this. Okay, so centroid, let us draw the medians first. So this is the midpoint. The vertices are A, B and C. These are the midpoints. Okay, let us take this as D, E and F. Let us draw the medians. These are the medians. Okay, so we have the medians like this. Okay, let us draw this again. Okay, so we have the medians like this. Let us take this as O. Okay, so we have the medium divides the triangle into three parts. Okay, so let us draw the, these are the three triangles. Okay, so this is triangle 1, this is triangle 2 and this is triangle 3. Okay, and let us take the angle as, this angle is alpha, this angle is beta and this angle is gamma. Okay, so we have the area of triangle 1, area of triangle 1 is equal to area of triangle 2 is equal to area of triangle 3. Okay, so area of triangle 1 is half of this length into this length into sine of alpha. So we have OB, this is O, so this is OB into OC sine alpha is equal to area of this one, half of OC into OA into sine of beta is equal to half of OA into OB into sine of gamma. Okay, so let us divide throughout by, so let us divide throughout by half of OA, OB, OC. Okay, so on dividing this by, let us divide this by half of OA, OB, OC. Divide this by OA, half of OA, OB, OC. Let us divide this by half of OA, OB, OC. Okay, so OB and OC gets cancelled. Here OC, OA, OC and OA gets cancelled. From here OA, OB cancelled. Half gets cancelled. So we have sine alpha upon OA is equal to sine beta upon OB is equal to sine gamma upon OC. Okay, and we have the forces as P is along OA and we have Q is along OB, Q is along OB and R is along OC. So from Lami's theorem, we have P upon sine of alpha is equal to Q upon sine of beta is equal to r upon sine of gamma. Okay, let us take this as k. So from here sine alpha is equal to p upon k, sine beta is equal to q upon k, and sine gamma is equal to r upon k. Okay, so let us place the values here. So we have p upon k upon OA is equal to sine beta is q upon k upon OB is equal to r upon k upon OC. So from this particular expression we have p upon OA is equal to q upon OB is equal to r upon OC. Okay, so this is the expression, that is p is to r, p is to q. So this we can write as, this expression we can write as p is to q is to r is equal to OA is to OB is to OC. Okay, so this is all about the problems on the concurrent forces. Okay, thank you.